Hello and thank you for joining me today. We're going to talk properties of fluids, and so we're going to kind of get into gases and liquids and different properties that they exhibit. And so specifically, we're going to talk about a guy named Archimedes. We're going to talk about Archimedes' principle, Pascal's principle, and Bernoulli's principle. And they have some equations with them, and we'll look at that a little bit today, but more in the next video, just to give you some practice there. So for starters, how does this thing float? This thing weighs multiple tons. And most things that weigh multiple tons would sink in the ocean. And so the question is, how does something this massive float? I mean, look, it's got a water slide up top, for crying out loud. And the answer is buoyancy. And so buoyancy, or the buoyant force, is an upward force exerted by a fluid on an object immersed in it. And so if you have a negative buoyant force, your object's going to sink. If it's neutral, you're going to be in the middle of the water somewhere. If it's positive, as is the case with the cruise ship, you're going to float, which means there's more force here than there is here. And so you're going to float, which is a good thing. Archimedes is he was a Greek philosopher that discovered this idea, and what he found was that if I have a 7-pound weight, and I put it in water, there would be the amount of water displaced is equal to the amount of force exerted by the water on the weight. And so his principle is the buoyant force is equal to the weight of the displaced water. So in the case of the cruise ship, there is a ton of water being displaced in order for the force to hold that ship above the surface. But that's the idea, is that the amount of water displaced is equal to the force upward. And what he figured out was that some guy was trying to steal from the king and he got caught, and I don't think it ended well for him. So in real life, this is what happens. So for example, a duck or a bird can sit on top of water because these forces are equal. If not, they're equal here, so the duck can stay up. These forces are equal, but this shell has more force down than it does up, which is why it sinks. And so that is Archimedes' principle in action where we see it. So really quick, how does a ship float and what is Archimedes' principle? Be able to answer those two questions. If you need some help, come see me or shoot me an email and we will talk through it. Bernoulli's principle. So Bernoulli worried about fluids and not so much sinking, but he's worried about pressures. And so he stated that as the velocity of a fluid increases, the pressure exerted by the fluid decreases. And we're talking perpendicular here. So if air is moving this direction, then the pressure going down decreases. Because it's sliding past, there's less pressure going down. And we're going to do a lab activity with this, so you'll get to see this kind of in action. But this is how airplanes work. There's more pressure underneath, so the airplane goes up. Birds do the same thing. This is how birds fly. This is how birds soar. This is how it works. There's more pressure underneath than above, and so the object is going to go up. Another one, if you spin a ball, for example, you play baseball, you throw a curveball, or you throw an object and you just spin it in general. The reason it turns is because the spinning ball decreases the pressure on one side. And so because the ball and the air are going the same way here, and they're going the opposite way here, there's more pressure up top, which pulls it downward. I can show you a video where a guy drops a ball off a bridge, and it goes a long ways because of this idea. And so we'll look at this. But this is Bernoulli's principle. This is where you can see it. You actually see this in real life. So go out and throw a baseball. Try to throw a curveball. Don't throw your shoulder or elbow out. But give it a shot. And that's Bernoulli's principle in action. All right, vocab time. There's a term called viscosity. I think you've probably heard of it before. If not, viscosity is a fluid's resistance to flow. So in this case, we have very low viscosities on this side and very high viscosities on this side. And we know that because these are already dumped and they were very small streams. These are thicker. They have a resistance to flow. They don't want to flow, so they have a high viscosity. Other places you see this, volcanoes. Lava has different viscosities depending on the type of lava. Other things do as well. Toothpaste. If you heat up honey goes faster. You can change the viscosity of different substances. So that is viscosity. All right. Oops. Let me make sure that was. Is that the right side? I don't know if that's right. Yeah. So review really quick. What is Bernoulli's principle? Where do you see it in action? So where can you find Bernoulli's principle? And what does viscosity tell you about a fluid? Those are your questions to answer now. And we have one more person to talk about. So we're going to talk pressure. Question, what is pressure? So pressure is, in science, pressure is the force exerted divided by the area over which it's exerted. And can you give me an example? So think of something you maybe can think of with pressure. For example, pounding a nail into wood. The reason that works is there's more pressure, a lot of force, a very small area. You can lay on a nail bed because there's a bunch of area and the force isn't so bad. So this is a bed of nails on top and a bed of nails on bottom, which I can't imagine is comfortable, but he doesn't look like he's in too much pain. Maybe he's dead. I'm not sure. But there's an equation for this. Pressure equals force divided by area. And we'll do another video on just this equation. But 1 Pascal, that's our unit for pressure, is equal to 1 Newton, which is our unit for force, divided by 1 square meter, which is our unit for area. And so this is pressure in action, that if you are closer to the ground, closer to the Earth's surface, you have a higher, there's more air pressure above you. As you climb up a mountain, you have a lower air pressure, and this is why it's hard to breathe when you climb a mountain. This is why they give you oxygen when you climb up mountains like Everest and things like that. But there's less pressure, which means it's harder to get oxygen into your body. Pascal's principle is that the force exerted on a fluid, the pressure applied to a fluid is transmitted throughout the fluid, is Pascal's principle. And you can see this in toothpaste, which works really nice. Okay, but if you squeeze the toothpaste tube, toothpaste goes in all directions equally. Up, down, out, it goes all directions, which is why it's really important that you squeeze from the bottom up. Otherwise, you get this mess. And there are 2 kinds of people, and I'm one of these guys. That's me, absolutely. So you see this all the time. This is one example. All right, here's your last set of review questions. So what is Pascal's principle? Where do you see it in everyday life? And then we will do some practice with his calculations. But thank you for staying with me today. I appreciate your time and attention and look forward to continuing this unit when we get back together. So enjoy the rest of your time, and I will see you later.